Hi students, today we are going to learn a new topic, that is line supports and substations. As you know that in previous classes we have completed symbols, fuses, cables and windings. The cables are generally used for the underground cables. Similarly, in the chapter we are going to learn overhead lines supports. Okay, so let us start our topic. Dear students, you should observe one thing. Our sun is giving ultimate power to all the creatures in the world in the form of light energy and heat energy to grow in healthy way. Similarly, our transmission and distribution systems also carrying electrical energy from remote generating stations to nearby our electrical equipments in our domestic as well as in industries or anywhere to live in comfortable zones. In transmission and distribution system, the supports are playing a vital role in bringing a reliable power from utility to user end. As electrical students, we have to learn the physical structure of the supporting parts like poles and towers. Let us learn. Now you can see here the different types of towers in our electrical field based on different applications. We all know that the population of our India, our country, is increasing day by day, which results in the existence of huge number of population in all the parts of our country. This large population needs a higher power of transmission or electric supply, and this requirement creates a need of number of transmission towers in the country to supply to remote areas in villages, tandas, to provide the electricity supply to the maximum people and to enable them to be a part of the story of successful India. It has become impossible to utilize the resources of few existing and introducing transmission powers. Thus, the increment in the number of towers is really important and essential also. Transmission towers simply means a tall structure which is usually made of steel and used to support overhead power lines. In previous classes we have observed underground cables. Those are also carry the power from a short distances from source to application oriented machines where it is not possible to transmit with the help of the overhead lines. But our cable system is very costly once the voltage increases further and further. the easy and best way of transmitting the electrical energy from a different place, remote areas, from generating station. It is a hydropower station. It is a very far from the thickly populated areas, and thermal power stations which is placed away nearby coal mines, and finally the nuclear power plant. It is far away from the populated areas. Hundreds of kilometers has to transmit whatever the energy generated in generating station to the receiver substations which is near to our city borders. To transmit the power, we have to use a different type of the towers. You can see in the figure that is based on the voltages. At the same time, we have to give the important, because our electricity is a bad master and good slave. So we have to be cautious while using our electricity. Otherwise, there is a possibility of fatal deaths. Induction is another problem. Hence, we have to maintain the ground clearance from live wire to the ground. If voltages increases further and further, we have to maintain the ground clearance. Hence, we required to propose different types of towers to support our conductors. At the same time, it has to withstand the heavy gale and winds during the thunderstorms. That means mechanical strength also is another important fact. Hence, we have to learn what is the physical structure of our poles and towers. As we know that in our India, we are transmitting the maximum power 765 kV. From 33 kV, we can use the poles, PSC poles, LT poles, 11 kV poles, and 33 kV we can use these PSC poles, rail poles, steel poles. Beyond 33 kV, whether 66 kV, 132 kV, and 220 kV or 400 kV, 765 kV. Further, so we know that 600 kV, the HVDC also we are using these towers. Okay, so let us see this. What is the tower meaning? So these are usually used in high voltage powers and come in different varieties and sizes. Their shape, height, and mechanical strength depend on the stresses to which they are exposed to the atmospheric conditions. It is the most important source of transmitting power. The transmission towers are used in high voltage in AC system as well as in a DC system also. They are also used in railway traction lines as well as in radio systems designs. So dear students, so let us see the basic tower, the pylon tower. Okay, let us see that one. So you can see this is one model of tower, steel tower. You can used in our nearly transmit the 400 kV lines. What do you mean by the transmission tower? So definition, you can see a transmission tower is a tall structure, usually a steel lattice tower used to support an overhead power line with the help of insulators. Okay, so here you can see the one real figure of pylon towers. Dear students, you can observe this is a steel structures and these are the insulators. You can see strings of insulators, and these are the conductors. You can see how they are the transmitting. and you can see the size of height depend on the, we have to maintain the ground clearance. Now, so this is one media between generating station to our receiving station. Okay, so it is comes nearby our border, city border, where there is a receiving station is present. Let us see that is also. This is a one receiving station which is placed nearby our thickly populated cities. Up to, it is just like this a transporting media tower. After that, you can see here also some steel structures also provided here, but these are the only supporting for these conductors, R phase, Y phase and B phase conductors. Okay, so now, so today we are going to learn what is the, how the steel structures presents, what are these dimensions, because we are preferring to draw our main towers. So in this class we are going to prefer, so 132 kV towers and 220 kV towers. Okay, so let us see that also. Now, dear students, so let us see the basic idea of pylon towers. Here up to this line, you can see up to this line. Okay, up to this line you can see. So this is a waist. So here the tower body, and so here the tower base, you can see this one, and that should be always earthed at ground potential, because all steel structures are ground potential. And so these different lattices are provided, diagonals, main leg, horizontal member, and this is a waist mainly. This after that it is going to the, so here is a conductor bounds, you can see this one, conductor bounds, and insulator string. This is the yellow color is a insulator strings. We can use whether one string or two strings, depend on the weight of the conductors. Whether you are going to use as two conductors, sometimes quadra conductors, four conductors also. Okay, so that is next. This is a cross arms. You can see cross arms, it support the insulating string, and you can see the beam here also. And overhead ground wires are essential to avoid the lightning. This is a ground wires. Okay, so this is a window. You can see this is a window. You can see that is a tower window, pylon tower window. So this basic idea of tower. So tower mainly it protects, it support our conductor. At the same time, it has to withstand heavy gale and wind, and it maintains a ground clearance. You can see, so what is the ground clearance from this one? Okay, so you can see one, this pylon towers has the different designs, physical structures. Our main aim is to support our live conductor and to create the ground clearance, but these towers are designed based on the tastedness of different engineers. You can see this is one of the pylon tower, this one. So you can see this one, how they are supported. Not only this one, you can see the electrical towers in different shapes. From here you can see the from low voltage to and higher voltage, maybe 765 kV. So once it's increasing the, it is a tower height also increasing, and mechanical structure of the tower also improved. Basically we can observe this tower is generally observed surrounding us. This is a normal general tower. It may be so 250 kV double circuit. So here instead of this one, so some people, some crazy people are designing towers in different shapes. At a glance you can see this is one of the interesting tower here. So you can see this is a double circuit. So this is the one circuit, this is the another circuit. Okay, so you can see the another robotic tower also. This is another interesting robotic tower. Okay, so next you can see the another important interesting tower is just like the human beings. So two human beings, how they are the supporting our conductors. You can see the what is the height of our live conductors. You can see the ground clearance. Generally these type of the towers are used in remote areas where there is some rivers and forest and hills presence. And you can see the another type of the tower also. So this is the one interesting tower with colorful windows. So double circuit this also. And so not only double circuit, you can observe here. So this is a one circuit, you can see the one circuit. So here you can see another figure. So here this is nearly, so 1 2 3 4 5 6 7 8 9. So nearly 1 2 3 4 5 6 7 8 9. So 9 conductors. That means here you can observe it. So this is one circuit. So this 3 is another circuit, 3 is another circuit. So 3 circuits this side and 3 circuits this side. That means total 6 circuits set. So we can transmit the power from bulk generating station to remote areas with help of these big size towers. With instead of using here, I can use only, so this 6, this one left, the right side 3 circuits and left side 3 circuits. At a time I can transmit the power. You can see it. Okay, so these are the different type of the towers. Not only, so these towers we can use another just like this. You can see this is a D type tower. So mainly it can withstand the heavy gale and wind during the any atmospheric calamity. So not only animal, you can see our transmission tower also in the form of human. You can see it, how big it is. Okay, so these are the different type of the towers in real world, but as electrical students we have to concentrate only general towers. Steel towers we are going to concentrate. Let us see, these are the ESC towers, extra high tension towers. It may be 132 kV and 220 kV. So whether single circuit or double circuits. So dear students, don't bother about the different type of the towers. So we are going to concentrate these 2 towers only, whether these 2 are the double circuits. So single circuit and double circuit we are going to draw in our drawing sheets with help of the drop down. Okay, so you can see here. So what is this one? So tower body. You are going to make it tower body, and after that you are going to the cross arms. You can see the cross arms. Only 2 things you are going to do it. Okay, so how you are going to do it, you should know. So first of all, you have to take it one single line from here, and you take the distance. Dear students, in this towers lesson, you have to draw these towers with the dimensions. Please keep in mind. In previous classes, we have done the windings, no dimensions, cables, no dimensions. But these towers, each cross arm, the height of the each face distance, the height of the tower for the 130 kV and 220 kV, you should maintain some dimensions. based on the dimensions you have to draw it. Okay, so it is a very easy, dear students. How to draw this one? So we have to learn it. Okay, so first of all you draw the one center line and take the baseline. They will give the dimensions, and so here you can take the some dimension here and take the slant line here, and you can fill this as per the structure mechanical strength, whatever you want you fill it. After that you take the another dimension, straight lines here, and lastly the ground wire purpose here go right, and you draw the here from the cross arms for the each face. Here each face you are going to draw it. So this is a total structure. Okay, so we will draw that one, don't bother about this one. Okay, so here you can see the one practical, the tower structure. So you can see here what is this one. So this steel structure is nothing but this one. So this insulator is nothing but this one, string, insulator strings. Okay, so this is the insulator's string, whether you are going to show or otherwise no need to show this one, but the structure, you can see the steel structure should be in the form of this one. So everything should be the dimensions. So this is a gap and this R face, Y face, what is the distance you have to maintain the uniform here and here. At the same time, what is the distance from this, from structure to this one, because this is a capacitance effect. So you are going to draw it. Okay, so dear students, don't bother about this one. So we will draw one figure. Okay, so let us see that one. A given dimensions. So you can take this one, so substitution this one. So one figure. So first of all, you draw the one line based on the some dotted line. You can take the dotted line, is better. Okay, so one dotted line, you take it, straight line. Okay, then you take the what is the foot area. So based on the area you take it, and so from this length, so assume some suitable length here and draw the cross lines here. Okay, now take the different portions. So you can take it this different portions and cross it as per your requirement. Enough. Sometimes if required, you can show this is also. Okay, so different shapes you can create it. And next, you take the another length of this line here and take the end top position. Now you take the one, so from this place to this place you take it. So you can take the this cross arm and you take the some length here and cross it. Now you take the another length here, take this one. So because they will give the what is the distance from this one, it will give. Now you will give the all distances. Okay, just you write it. This is the under face. Next, you are going to get it. So these are the structure, dear students. Okay, so here everything is show the some insulators. So this is the basic thing. Okay, so this is the one single circuit tower, dear students. In double circuits, so as usually you write it. Take the one line. Okay, once again you can see it. Whatever the base foot is given, and you take the approximately, for example 4 meters is given, you take the here 1.5, 1.5, you can take this length and join these two lines here. Okay, then you can create, so as per your requirement, so here you can write it here. This is a mechanical support. Okay, so you can show just like here. All are the just mechanical supports. Okay, so this one. Now take the whatever the length is given here. Okay, take this one length up to this one here, and suppose you require the double structure is required. For example, you require the another face, for example OR face is required, then write it. So take the from this length, what is the distance, and what is the distance, you take it and join these two lengths. Okay, then you just remember this and just mechanical step. This is one face. After this, you are going to create another Y face. So you can take the Y face, and from this length you can create another length, from create another length and write. So you have the drop down, don't worry. Okay, next you are going to RYB, another face. So blue you are going to write. Next, here you give the tail, this one, and so this is a OR face, Y face. And finally, so you are going to select the end supporting part. Okay, so that is the end ground wire purpose we are going to use it. So here height length, so we are going to get this one. Okay, so this is a lengths, different lengths. Okay, so this is a one tower, you can see dear students. This is a double structure, DOU, double circuit, because OR face, Y face, B face, this is a one circuit, here is another circuit, whereas in this case single circuit. So because here R face, the Y face and B face. Okay, your aim is to draw this simple only. You will give the dimensions, what is the dimension, what is the height, what is this height, what is this height, what is this height, what is the length, everything will give, but you have to prepare neatly these diagrams. So our aim is to draw 132 kV single circuit, and double circuit. Okay, so single circuit and double circuit at the same time. So 220 kV also single circuit and double circuit. Okay, in this class we are going to draw only these four figures, dear students. How we are going to draw that one, what is the physical, the structure presence in real field, I can show you. Okay, so there is a one animation I created for you. So every structure, how to start first line, second line, third line, fourth line. Okay, complete just like similarly what I have seen, I have drawn here, you take similar way. Okay, so dear students, let us see the animation figure. Okay, it's very easy, dear students. Dear students, what is this one? Dear students, let us conclude today's topic, that is we have seen that salient features of electrical supports, such as our transmission towers simply means a tall structures which is usually made up of steel and used to support an overhead power lines. The towers are usually used in high voltage powers and come in different varieties and shapes we have seen. Their shapes and height and mechanical strength depend on the stresses to which they are exposed. And also we have seen that how to draw EHT towers with freehand sketches. In next class we will learn 132 kV single circuit and double circuit and 220 kV steel towers with single circuit and double circuits. We will draw with standard given dimensions step by step with animations. Thank you dear students for listening my class.